Now we are going to discuss about some quantities related to SHM. First one is displacement. I have already discussed about this point in the previous videos. Suppose this is SHM with the mean position at O, the final position at B, and another extreme position at C. So B and C are the extremities and O is the mean position. Then the particles start from a point, suppose D. So you can take this to be the x-axis. So if the particle starts from the mean position, or if you can write the equation with respect to the mean position, we can get that x is equal to a sine of omega t plus alpha, as I've discussed about the phase relations in the previous video. So this is one amplitude relating to a. The value of that amplitude is a. Omega t plus alpha, that means the shift of this position from the point O. Now this is from the mean position. If we write the equation from the mean position, and x is equal to a cos of omega t plus alpha, that means from the extreme position. That means if we write the equation with respect to the mean position, it will be sine. With respect to the extremity, it will be cos. Now if we can take alpha is equal to 0 and write the equation like this, x is equal to a sine omega t. That means we are taking the particle starting its motion from the mean position. That means start from mean position and try to find out the velocity, or rather you can do it in this way also. X is equal to a cos of omega t. That means also it will start from the extreme position. Start from the mean position is this, start from the extreme position is a cos omega t. Now trying to find out the equation or the formula for the velocity. Now what is from this equation, from this one, x is equal to a sin omega t, we get, or rather from this one, not this one, a sin omega t plus alpha. So what is omega t plus alpha? Sorry, sine of x by a. Therefore cos of omega t plus alpha means root over 1 minus x square by a square. Then this relation comes from a trigonometric relation of sin square theta plus cos square theta is equal to 1. Replace the value of sine in that equation, find out the value of the cos. It comes out to be plus minus. You can write a plus minus here also. Root over 1 minus x square by a square. Now the expression for the displacement, that is x is equal to a sine of omega t plus alpha. If we do the derivative of this equation with respect to t, that means a, the sine becomes cos omega t plus alpha, and the derivative of this part omega t plus alpha, omega t with respect to t becomes 1. So omega comes out and alpha is a constant, that means the derivative form is 0. So a omega cos omega t plus alpha, we have already found out the value of cos of omega t plus alpha, that is this one. So we can replace that as 1 minus x square by a square with a plus minus sign in front. So plus minus a omega a square minus x square by a. So a and a gets cancelled, so plus minus omega into a square minus x square. A omega, this one, so a comes out, so a and a gets cancelled, and v, dx by dt means it is v is equal to, this is the formula for the, or the general formula for the value of velocity. Now at extreme point, what is the value of x? X means equal to a extremity, that means if this is the mean position, so this position means a displacement of a. So x is equal to a means extreme point. Now replace the value of x here, we get v is equal to plus minus omega into a square minus a square, that means equal to 0. So v is equal to 0 comes out for the position of x, or the value of velocity for the extreme point. Now at mean point or mean position you can write what is the value of x. It is 0. So v is equal to plus minus omega a. X is 0, so square root of a square means another plus minus. You can write this as minus plus also. Omega is equal to minus plus omega a. Now when the particle is at the mean position, that means x is equal to 0, we get the value of x or v as plus minus omega a. That means this is the maximum value. Value of v as omega a is the maximum value, and the value of v as 0 must be the minimum value. Now see, acceleration. The last equation for v was a omega cos of omega t plus alpha. This was the expression for velocity. Now we know the derivative of velocity gives the acceleration. So cos becomes minus sine. So minus a and 1 omega from here becomes a omega square sine of omega t plus alpha. So derivative of cosine function gives sine, and the derivative of this part omega t plus alpha gives 1 omega here. So minus a omega square. Now similar to the previous case, if we put the value of sine omega t plus alpha as minus a omega square into x by a. What was x? It was x is equal to a sine omega t plus alpha. So what is sine omega t plus alpha? X by a. Again a gets cancelled out. A is equal to minus omega square x. Now if you remember, this was the equation that I had written as the differential equation by multiplying both sides by m. Ma is equal to m omega square x. That was f was proportional to minus of x. So this is the equation that we had derived already. So a is equal to minus omega square x. From this only we had derived the differential equation formula, d square is dt square plus omega square x is equal to 0. Now again the special cases means first case is at mean position. Now what is the value of a at mean position? Mean position means x is equal to 0. That means a is also equal to 0. By replacing the value of x is equal to 0 in this equation, we get a is equal to 0. Therefore the acceleration at the mean position is 0. And now at extreme position x is equal to a, so a is equal to minus omega square a. So this also is the maximum value of the acceleration. This is the minimum value of acceleration. So if we take all the three things, that it's the displacement, velocity and acceleration, into one place and try to write everything in one line, that means these are the three positions. This is known as the mean position. This is one extreme. So what is the value of velocity here? Velocity in this position is the maximum. That means a omega. Velocity here at the extreme position is 0 because the particle here stops and it comes back. Now the value of a at the mean position is 0 and the value of a at the extreme position is minus omega square a. That means when the velocity value is 0, we are having the acceleration at the maximum. That means the particle or the force or the restoring force, if you can call it, the restoring force is at its maximum. Mg sine theta, theta is at its maximum, so sine theta is maximum, so mg sine theta is also the maximum value. For the maximum value of force, we can derive the maximum value of acceleration. When the particle reaches the mean position, the acceleration becomes 0. That means this acceleration has died down to the value of 0, thus increasing the velocity from 0 to a omega. This value of velocity is again the maximum value at this position. So the particle stops here and comes to this point with a velocity which is the maximum velocity. That means the kinetic energy is present here, which helps the particle to move forward in this direction. The particle does not stop here. The particle moves in the reverse direction because of this velocity. Now, if we can write the value of time period, we know t is equal to 2 pi by omega, and from the expression of acceleration, that is a is equal to minus omega square x. So a is equal to minus omega square x. Now what is omega? Is equal to a by x. Taking the magnitude, only the magnitude into account. So omega square is equal to x by x. Omega is equal to square root of a by x. Now what is t? 2 pi by omega, that means x by a. 2 pi by omega means 2 pi root over x by a. That means we can write the equation as 2 pi root over, what is x? X is displacement by acceleration. So in statement it is t is equal to 2 pi root over displacement by acceleration. Now we take one question. Which one represents an SHM? These are three equations: sine 2 omega t, sine omega t plus sine 2 omega t, sine omega t cos 2 omega t. 1, 2, 3. Now you have to check each and every one whether this or whether any one represents SHM. The first one is, we can take y is equal to sine 2 omega t. So dy by dt is equal to, or we can write v also here. That means 2 omega cos 2 omega t, acceleration d square y by dt square. So derivative of this function again. So 2 omega minus 2 omega, sine 2 omega t. So becomes minus 4 omega square sine 2 omega t, minus 4 omega square sine 2 omega t. Now here we can replace sine 2 omega t with y. So it becomes minus 4 omega square y. So a is equal to minus 4 omega square y. So this represents SHM because the expression for a is similar to that, like this, minus omega square x. So 4 omega square, that means 2 omega whole square into y. This is the equation for SHM. So this equation and this equation looks to be of the same pattern. That means it is an SHM. Second one, sine omega t plus sine 2 omega t. Now the second equation, I think I've written it wrong. Sine omega t plus 2 cos omega t, and sine omega t plus cos 2 omega t. This one is correct. So sine omega t plus 2 cos omega t. This is y or x, as you can write. Y is equal to sine. So v is equal to dy by dt. That means omega cos omega t minus 2 omega sine omega t. So omega cos omega t minus 2 omega sine omega t. Again derivative of this equation, that is d square by dt square is equal to minus omega square sine omega t minus 2 omega square cos omega t. Now if we take omega square common from both these equations, from both these parts, or rather minus omega square, we get sine omega t plus 2 cos omega t. Now what is sine omega t plus 2 cos omega t? This was the equation for the displacement. So you can write minus omega square y. Again, we found out this will be a SHM. Now the last of these equations is y is equal to sine omega t plus cos 2 omega t. So similarly we can do v is equal to dy by dt, that means omega cos omega t minus 2 omega sine 2 omega t. Now a is equal to d square y by dt square. That means derivative of this function means minus omega square sine omega t minus 2 omega whole square cos 2 omega t. Take minus omega square common from both, we can write sine omega t plus 4 cos 2 omega t. Now this expression and the original expression of y does not match. We have a 4 here. So we can write this can be an oscillatory motion but not an SHM, because the reason why it is not an SHM because it is not yielding the same result as the previous two cases, that is a is equal to minus omega square y. So this one can be oscillatory motion, oscillatory, but not SHM. Second problem, there are two equations given. y1 is equal to 10 sine of 3 pi t plus pi by 4 and y2 is equal to 5 into sine 3 pi t plus root 3 cos 3 pi t. They have asked to find the ratio of their amplitudes and phase difference between them. Now the first equation, y is equal to 10 sine of 3 pi t plus pi by 4. It's a very simple equation, not a complicated one. So from this we can write the amplitude as 10 and the value of potential difference, that means the phase is pi by 4. For the second equation, y2 is equal to 5 sine of 3 pi t plus 5 root 3 cos of 3 pi t. So there are two simple harmonic motions here, two SHMs here. So you have to do the calculation for amplitude in a different way. That means take this 5 to be equal to a cos of phi. Take this 5 root 3 to be equal to a sine of phi. Now squaring the two equations and adding them, we get a square cos square phi plus a square sine square phi is equal to 5 square plus 5 root 3 a square. So how much is this? It is a square. Take a square common. So cos square phi plus sin square phi is equal to 1. So 25 plus 75. That means 100. That means a is equal to 10. So if you can name the amplitude of the first one as A1 and amplitude of this one as A2. So the ratio of their amplitudes, ratio of their amplitudes. The first one is an amplitude of 10, the second one is also an amplitude of 10. So it becomes 1:1. Now the phase difference. Now when you have found out the value of A2 here as 10, we can also find out the value of phi, because if we divide these two things, a sin phi by a cos phi, a sin phi by a cos phi means 5 root 3 by 3, 5 root 3, so a cancelled, tan phi is equal to root 3, so phi is equal to 60 or pi by 3. So the phase difference is pi by 3 minus what was that part? Pi by 3 minus pi by 4 equal to 12. 4 pi minus 3 pi is equal to pi by 12. So pi by 12 is the phase difference. So the ratio of the amplitudes was 10 by 10, A1 also 10, A2 also 10, so it becomes 1:1. And potential difference, the first one, this one is pi by 3 and the previous one was pi by 4. So it becomes pi by 12 radians.